I'm ready to take some measurements on the oil pump components, and I've removed the cover, and that's secured by 4 of these 6mm bolts. Now, the pattern for the bolt holes in the cover are not symmetric, and second, there's a bevel here on the top edge of the cover. The idea is to make sure the cover can only go on one way with the bevel to the top. So that's why the bolt holes are not symmetric. On the inside of the cover, this is the O-ring that seals the cover, and I'm going to replace that. And you'll notice there's some machined areas in the cover. That's the reason that it can only go one way, because those machined areas line up with the components here inside the pump so that oil can come in, be pressurized, and flow out of the pump. Now, the pump consists of an inner rotor which has 4 lobes attached to the end of the camshaft, and then an outer rotor with 5 lobes. Now, this inner rotor spins, and the outer rotor also moves around inside the bore of the engine case. And you'll see that there's large voids and small voids as you move around the perimeter of the outer rotor. So oil can be brought in, and then it gets squeezed as the voids become smaller, which is what pressurizes the oil. Now, to do measurements, I use feeler gauges because some of these measurements are clearances between parts. And what I do, since the measurements are given as a range, is I'll use a set of them that cover the range pretty close. Now, the ranges are in millimeters, but my feeler gauges are in thousandths of an inch. But underneath it is printed the corresponding millimeters. So for instance, where I'm looking at the clearance between the outer body of the oil pump and the outer rotor, that distance is from 0.1 millimeters to 0.171. So I can pick a set of gauges that will bracket that range, like 0.102, 0.127, etc. And then I can insert them in between like that. And if it slides easy, then I go up to the next one. And when it gets to be almost impossible or really tight, like this one right here, then I call that the right measurement. So that's how I'm going to work forward. So I do take a measurement here between the pump outer rotor and the case to get that distance. And I also want to take a measurement between the inner rotor and the outer. So I can run right through like that and work my way through the gauges on the range until I figure out what that distance is. Now, the other measurements have to do with the thickness or the diameter. So you can pull the outer rotor out, and I use a vernier caliper, and I can measure the thickness with that caliper, and I'll usually get about 3 measurements around the circumference. And I can also measure the diameter of the outer rotor, and I'll do it the same way. I'll take 3 measurements around the circumference. So I can get the outer rotor diameter and thickness. Now, the inner rotor pulls right off the cam on this model bike, and if you look inside, you'll see there's some flats machined on the hole of the inner rotor, and they match up with flats on the camshaft. And the distance here is the thickness, so I'll take a measurement of that thickness. There's another measurement that I need to make, which is the end play between the rotor and the body of the engine block. So what that is that the face of the rotor is recessed just a little bit in relation to the face of the block, and that's called end play. I find that if I use a Allen wrench, there's a flat face right along this edge of the Allen wrench, which lines right up with the foot here. So what I do is I lay the wrench with the foot pointing straight out, right across the block and across the rotor, just like that. And then I can slide a feeler gauge in between the rotor and the flat spot on that Allen. So that's how I can get a measurement on the outer rotor. Now I also need to do that on the inner rotor. So I just pull the outer one away and I put the inner one in. Now when you put the wrench across the inner rotor, don't get it across the end of the camshaft, because that's proud of the face of the rotor. You want to get it off one of the lobes like this, and then slide your feeler gauge in. Probably from this edge is the easier way to do it. And then you can get a good measurement on the end play on the inner rotor. One other measurement I can take is the depth of the body. So I can use my vernier caliper and use this end, and I can get a pretty good estimate of the depth of the body of the oil pump. The other thing I want to do is look at them visually and inspect them. So here is the outer rotor, and you can see there are scores around the perimeter, and there are scores on the face of this rotor, both sides. And so that's not what I'd like to see. That's not good. And on the inner rotor, you may be able to see it, but there are scores right along the top of the lobe on all four lobes. So some hard stuff has gone through the pump and scored those surfaces, and you can see the scores on the face of the inner rotor, again, on both sides. That's not good either. But I'll make a condition assessment and then decide whether I can continue to use these parts or whether I actually need to replace the entire oil pump. If I do that, I will replace the inner rotor, the outer rotor, and since this also wears against them as the pump cover, I would replace it as well. So if I do anything in the oil pump, generally I'm just going to replace all three components. They mate together and wear together, so it's probably a good idea to just treat it as a complete set. This table summarizes the measurements I took, and as you can see, a number of them are marginal, and the inner rotor end play is bad. Consequently, I'm going to replace the two oil pump rotors and the cover, effectively replacing the entire oil pump, as I don't think it's serviceable.